All right, the last thing we have to touch on in this section is even and odd not numbers, even and odd functions. So you learned about this in 111, who knows when you took that, but what it says to be even, there's two things, is when you put in a negative, you negate that input, whatever it is, make it opposite, it does not affect what it spits out. All right? So an example of this that I think you would be familiar with would be y equals x squared. If I negate that input, it doesn't change what I originally had. Okay? The other thing visually is it's symmetrical around, or about, I should say, about the y-axis. So if you can think about a parabola, I'll go in here. I'm going to put y equals x squared. Notice how when you put in -1, right, it would spit out 1, right? And then if you put in a +1, it will spit out also a +1. And so that's what I mean about being even. You put in a negative, it does not affect what it originally put out. Or the opposite, I should say, not really necessarily the negative. So thinking about that, let's pull up that beautiful unit circle again. Look here, when you do cosine of pi over 6, we get out root 3 over 2. But when we do cosine of negative pi over 6, wait a minute, we still get the same value. Positive pi over 4, we get root 2 over 2. But negative pi over 4, we also get root 2 over 2. So this is why cosine functions are even. Where the other function is odd. So you negate or make opposite the inside, it will affect the output. Oh, that's just my computer saying hi. So another example that I think you'd be familiar with would be x to the third. Well, if you negate your input, it will negate the output because a negative to the third power would remain negative. And let me go back to Desmos. Let's go ahead and make that to the third power. And I'm just trying to remember where my little caret is. Where's my caret? Do you guys see it? There we go. Okay, so notice how that 1 is not on there anymore, but so when you put in the original 1, it spits out 1. But when I negate the input, it will also negate the output. If I try another one, like I put in 2, it would spit out 2 to the third is 8. So it spits out that coordinate. But when I put in a -2, if it's odd, it should also negate the output. And I can't see it. I'll get rid, and there it is, that black coordinate. The other thing visually is it's symmetrical about the origin. All right, if I go bring this guy back, and now I'm going to look at my y values for my sine. Well, sine, when I put in positive pi over 6, I get out 1/2. But when I put in negative pi over 6, I get out negative 1/2. I put in positive pi over 4, I get positive root 2 over 2. I put in negative pi over 4, I get negative root 2 over 2. So that's confirming that your sine functions are odd. cosine functions are even. So nice thing is if you do know this, right, and you get this, you retain this information, if I say, let me actually get rid of that and change colors for us. If I say find sine of negative 11 pi over 6. Well, you could just find that on your unit circle, right, going in the clockwise direction, or you could figure out, oh wait, I know what 11 pi over 6 is, and then I would just negate whatever it is. And I should know this, and it will be negative 1/2. Let's make sure of that. My thing is not bringing up anymore. Okay, and then if I say, okay, wait, I want to find cosine of negative pi over 4. Sure, you can find that on your unit circle, but just what is cosine of pi over 4? Because these are equal. So it would just be root 2 over 2. Another way I could have said this sine business too is you bring the negative on the outside. And so odd functions mean it negates the output. Even functions means you can ignore it. All right.